Hello students, I am Kinjal Parmar. Welcome back to the video lecture series of microprocessor and microcontroller. Today we will discuss AVR Timer 0 programming. So let's start with what is Timer 0. So in AVR we have a timer circuit. A timer is a circuit which is used to count an event and also generate desired delay. In AVR family, 8MEGA32 has 3 timer: timer 0 which is of 8-bit, timer 1 of 16-bit, timer 2 which is of 8-bit. Each timer have TCNT and TCCR for timer programming. To program this timer, we have two types of resistor, that is TCNT and TCCR. So let's discuss about what is TCNT resistor and what is TCCR resistor for timer 0. So here we have a TCNT 0 resistor for timer 0. For timer 0 there is a TCNT 0 resistor, and as timer 0 is a 8-bit in a 8MEGA32, thus TCNT 0 is 8-bit. The TCNT 0 resistor is a counter. Upon reset, the TCNT 0 contains 0. It counts up with each pulses the content of the timer, and counter can be accessed using TCNT 0. So here we have a total 8-bit of a TCNT 0. In TCNT 0, we can load a value which we want to count. Okay, in TCNT 0, we can load a value which we want to count for a desired delay. So this is TCNT 0 resistor. Next, how we can calculate the values for TCNT 0 resistor? So for that, follow these steps. Calculate the period of a timer clock using formula T clock is equals to 1 upon F. So first of all, we have to calculate a time durations. We can calculate time durations by frequency of our AVR. Okay, so by applying frequency 1 upon F, we have our time durations. Now this time duration is basically used to divide our desired time delay. So we have this T clock durations and we have a desired time delay. So divide desired time delay by this T clock. So we have a amount that how many clocks are required for a desired time delay. So here we have a sum either integer value or fractional value. So use these values and perform subtraction. 256 minus n. Now here 256 is used as we have a TCNT 0 is of a 8-bit. So 2 raised to 8, that means we have a total 256 value. So perform 256 minus n. Here n is a decimal value of step 2. Okay, decimal value of step 2. So we have a we have a data. Now this data is converted either in a hex or remain original in a decimal number. So we have our value for TCNT 0. Again, divide a clock frequency. Okay, first divide a clock frequency 1 upon F. So we have our time duration. Now this time duration is used to divide our desired clock. So it gives a count that how many clocks are required. Then perform a subtraction, that is 256 minus this desired time delay divide by T clock. Okay, so this is we have a decimal value which we can load in a TCNT 0, or we can convert this value in a hex. So we can use either hex format to load a value in a TCNT 0. Here we have one example that how we can calculate that value. So calculate the value of TCNT 0 to generate delay of 6.25 microsecond. Okay, here we want to generate a delay of 6.25 microsecond. We have a frequency, clock frequency is a 8 megahertz. We have a frequency that is 8 megahertz. So calculate first T time durations by calculating 1 upon F. So here F is a 8 megahertz. So 1 upon 8 megahertz. So it gives 0.125 microsecond. Okay, so this is how we can calculate T clock. Then use this number 0.125 microsecond to divide our desired delay. So this desired delay is divided by this 0.125. So 6.25 microsecond upon 0.125 microsecond. So we have a 50 clocks. Okay, so to generate this 6.25 microsecond, we need 50 clocks. Now if we want 50 clocks, so we have to calculate that values up to the count. Okay, so here perform 256 minus, and that means 256 minus 50. So here we have a 206. So to calculate desired delay of a 6.25, we need to count 206. Okay, we need to count 206 times. So we have a desired time delay. So load this 206 in a TCNT 0 in a decimal format, or we can convert this 206 in a hex format. So here we have a hex value CE. Okay, CE is our hex value. So this is how we can calculate the desired time delay by calculating values of TCNT 0. So this is about TCNT 0. Now let's discuss about TCCR 0 resistor. So this timer 0 is an 8-bit resistor used for control of timer 0. TCCR 0 is an 8-bit resistor used for control of timer 0. Timer 0 has TCCR 0 resistor for setting modes of operations. In counters there are varieties of modes. Okay, so to set that mode we have a TCCR 0 control resistor. The timer resistor are located in IO resistor memory. Therefore, read or write from timer resistor can be done using in and out instructions like the input output resistor. So to send any value in a TCCR 0 or in a TCNT 0, we have to use in and out circuit. Here we have a TCCR 0 bit. So here we have a total 8 bits for TCCR 0. Each and every bits are located at a precise locations. Okay, here higher bit is of a FOC 0, then WGM 00, COM 01, COM 00, WGM 01, CS 02, CS 01 and CS 00. All these bits have a specific functions. Okay, so let's discuss all the functions. So first is a FOC 0, force compare match. Okay, force compare match. So this is write only bits which can be used while generating a wave. Writing a 1, it causes the wave generator to act as if compare match had occurred. If we want to stop our counters and if we want to match our desired value, so we can make this bit 1, so it make forcefully compare match. Okay, so it generate match when this bit is equals to 1. Okay, so this is a force compare match for timer 0. Then next is the WGM 00 and WGM 01. These all are the wave generator modes. So timer 0 can work in a 4 different mode: normal mode, phase correct PWM, that is pulse width modulation, then in a CTC mode, that is clear timer on a compare match, then fast PWM. So to decide which mode we want to use to generate a delay, we have to decide the values of WGM 00 and WGM 01. So if WGM 00 and WGM 01 is equals to 00, that means normal mode. If 01, then that is a CTC mode, that is clear timer on compare match. If 10, then PWM phase correct mode, and 11, then there is a fast PWM mode. Okay, so these all are the modes. In a timer, generally normal and CTC modes are most widely used. What is normal mode and what is CTC mode? So let's discuss about this normal mode. Normal mode in which the content of the timer counter incremented with each each clock. Okay, content of the timer counter incremented with each clock. It counts up until it reaches its maximum of 0xFF. Okay, so it counts values. When it rolls over from 0xFF to 00, it sets a high flag bit called TOV0, timer overflow for 0. This timer can flag be monitored to stop our counters, okay, for desired time delay. So in a normal mode, content of the timers is basically incremented and it counts up to the maximum value, that is FF, because of 8 bit it counts only 2 raised to 8, total 255, right? So when it rolls over from the value to the maximum of 0xFF, then TOV0 flag is set whenever it counts up to the FF, and after FF to again 00, this overflow occurs. That's why this TOV0 will be activated when it counts fully. Next is a CTC mode. So in a CTC mode, timer is incremented with the clock. It counts up to until the content of the TCNT 0 becomes equal to the OCR 0. That means compare match resistors. Okay, so whenever we have our counter values of a TCNT 0 and it becomes equal to OCR 0, then our counter will stop. So the timer will be cleared and the OCR 0 flag will be set when the next clock occurs, and the OCR 0 flag is located in a TIFR resistor. So this is normal mode and CTC mode. Both counts according to that, but in a normal mode it counts up to the maximum value FF. In a OC0, in a CTC mode it counts up to the value of OCR 0. So this is normal and CTC mode. Now next we have a TCCR 0 bit resistor. So here we have a COM0100, that is compared output mode. So these bits controls are used for waveform generator. So if 00, then normal port operations, 01, then toggle OC0 on a compare match, 10, then clear OC0 on a compare match. If 11, then set OC0 on a compare match. Generally these bits are 00 for normal operations. Then next we have a CS 020100. These are all the timer 0 clock selectors. So what kind of a clock we want to use? According to that, here we have this all bits 000, that means no clocks, or 001, that means clock but no prescaling. Then 010, then clock 8. These are the prescalers, okay, clock, but we have a prescalers over here. That means clock is already prescale using this factor. So if 010, then by factor of 8. If 011, by factor of 64. 100, then factor 256. 101, then 1024. This last two bit 110 and 111 are used when we want to use this T0 pin of 8 mega 32. So this provide external clock on a T0 pins. Okay, so this is a timer 0 clock selector. Generally for a normal clock, this 001 is select for a CS0 to CS01, CS00. Okay, so how we can find out the values of TCCR0? So here we have one example that find the values for TCCR0 if we want to program timer 0 in a normal mode. That means we have a WGM00 and WGM01 is equals to 00. No prescaler. That means we have to just use normal clock frequency. That's why CS02, CS01 and CS00 is equals to 0001. So we have a values of TCCR0 is equals to 01. So this is how we can calculate content of TCCR0. Now let's discuss about how we can program our counter. But before that, let's discuss about this resistors TIFR TIFR, in which we have other flags are there. So each timer has TOV flags and OCF flags. This timer 0 has TOV 0 flag, and when a timer overflow, its TOV 0 flag will be set. TIFR register contains the flag of all the different items. That means it contains the flag of timer 0, timer 1 and for timer 2. So here we have a OCF2, TOV2, then ICF1, OCF1A, OCF1B, TOV1, OCF0, TOV0. So let's discuss about this. Here we have a first TOV0, so timer 0 overflow flag bit. So when 0, that means timer 0 did not overflow. 1, that means timer 0 has overflowed. Then OCF0, that means timer 0 compare flag bit. So whenever it will 0, that means compare match did not occur. 1, that means compare match occur. This OCF is used for CTC modes, okay, and this TOV used for normal mode operations for timer 0. Then for timer 1 we have all other bits. So TOV1, timer 1 overflow flag, so 0, that means timer 1 did not overflow. 1, that means overflow. OCF1B, timer 1B output compare flag, so 0, that means compare match not occur. 1, that means compare match occur. Then timer 1A, as timer 1 is of a 16 bit, it is divided into a 2 part of a 8 bit, timer 1A, timer 1B of a 8 bit. So OCF1A, timer 1A output compare flag bit, so 0, that means compare match did not occur. 1, that means compare match occur. ICF1, that means input capture flag. This is the special function of timer 1. Next we have a TOV2 flag, that is timer 2 overflow flag. So it is 0, then timer 2 did not overflow. 1, that means timer 1 has overflow. OCF2 for timer 2, so 0, that means compare match did not occur. 1, that means compare match occur. Now these all are the flags in which this TIF register can be counted depending on the conditions. Now let's discuss about the programming of a timer 0 in a normal mode. So to program timer 0 in a normal mode, first load the content of TCNT 0 register with the initial count value which we can calculate earlier, right? So to load first TCNT 0 register for a desired durations, then load the values of TCCR0. First value of a TCNT 0, then values of TCCR0 indicating the which mode is to be used and the prescaler option. Then keep monitoring the timer overflow flag. Okay, continue keep monitoring the overflow flag TOV0. If TOV0 is equals to 1, that means timer count all the values and we have our desired time delay. So as soon as this DOV0 is equals to 1, get out the loop, and when TOV0 becomes high. Okay, so this is how in a timer 0 in normal mode we can program. So here we have a timer 0 program in a normal mode in a assembly language. Assuming a clock frequency, write a program to generate a delay of 6.25 microsecond with normal mode and no prescaler. Now for a 6.25 microsecond we calculate values of TCNT 0 which is CE, and where we calculate the values of TCCR0 for normal mode, clock frequency and no prescaler. So the value of TCCR0 is a 0, 1, right? So we just use over here. So this first line is LDI R20 0xCE. We want to load this value in a TCNT 0 register. So we use dummy register and then we load this value, and then we may use in and out instruction. So out TCNT 0 R20. So here we load the values of timer 0. So TCNT 0 is equals to CE over here. Okay, now next we want to load a value in a TCCR0. So again load the value in a R20 register. So R20 is equals to 0, 1. Okay, now load this value in a TCCR0. So TCCR0 is equals to 0 1. That means timer 0, normal mode, internal clock and no prescaler. These values we calculate from the bits of TCCR0. Now we have to continuously read the values of TIFR. So here we use these instructions in R20 TIFR. So in a TIFR, whatever the contents are copied in a R20, and by reading particularly TOV0 flag, so we use here SBRS instruction. So SBRS R20 TOV0. So if TOV0 is equals to 1, then skip next instructions. So here whenever TOV0 is equals to 0, then it execute the next instruction, which is RJMP again. So again values of TIFR are copied in a R20 and it checks the values of TOV0. So continue the values of until TOV0 is equals to 0. Whenever TOV0 is equals to 1, so it skip the next line, that means RJMP again it skipped and it goes to the next line. Okay, so here SBRS instruction is used to check the values of a TOV0. If TOV0 is equals to 1, then it skip the next value, otherwise it jump to the locations of a TIFR. So continuously it jumps and it monitor the values of TOV0. As soon as it becomes 1, it skip the next instruction, and next instruction is LDI R20 0x, and it will goes in a TCCR0. So TCCR0 is equals to 0. So whenever TCCR0 is equals to 0, so stop the timer 0 and TOV0 is also clear over here and return. Okay, so this is the normal mode operations in a assembly. First load the value in a TCNT 0, then load the value in a TCCR 0, then check the TIFR. So whenever TOV0 is equals to 0, we have to stay over there continuously, we have to check the status, and as soon as TOV becomes 1, we have to jump out there. Now let's discuss normal mode operation in a C. So C programming, it's very easy. Assuming a clock frequency, write a C program to generate a delay of a 70 millisecond with the normal mode 1 gem 8 prescaler. So for a normal mode and 1 gem 8 prescaler, we have to calculate the values of TCCR0, and for 70 millisecond we have to calculate the values of this TCNT0. So clock is a 8 megahertz, so our T clock is equals to 1 upon 8. Now here we have a prescaler 1 gem 8, that means we have a T clock, so we have to divide this by 8. Okay, so 8 into 1 by 8, so we have a 1 millisecond, because here prescaler 8 is used, so 1 by 8 is prescale by 8, so 1 by 8 into 8, so 8 cancel out, we have a 1 millisecond. Now our desired delay is 70 millisecond and our clock duration is 1 millisecond, so 70 clocks needed. So for a 70 clocks we can perform 256 minus 70. So here we have our value, and this value is converted into this hexadecimal. So here we have a values of TCNT0. So first include AVR IOH, then use this void T0 delay, and then TCNT0 is equals to 186, then TCCR0 is equals to 0x02. So load the values, timer 0, normal mode 1 gem 8, that's why it is 02. Then while TIFR and 1 into TOV are equals to 00, wait over here. Whenever it becomes 1, then execute next, that TCCR0 is equals to 0, TIFR 0x is equals to 00. So it will clear the TOV0 flag. So using C programming, we can easily program a timer. Just TCNT values of TCNT0, TCCR0, then use while loop. So wait over here. Whenever it becomes 1, then execute next instruction. So this is how we can program timer 0 in normal mode. Now let's discuss about timer 0 in a CTC mode in a assembly. So assuming a clock frequency is a 8 megahertz, write a program to generate a delay of a 25.6 millisecond. Use timer 0 CTC mode with prescaler of 1024. So due to prescaler 1024, we have a 1024 upon divide into 1 by 8, that means 0.25 microsecond. So here we have a 128 microsecond. Now to generate 25 millisecond, we have to wait 25 millisecond divided by 128. So we have a total 200 clocks. Okay, and now we have to load this 200 values in our this TCCR0, but here OCR0 register use. So here we use values of this is for it OCR0 is equals to 200 minus 1, so 199. So in a CTC mode we load 199. So it increment values up to calculate the values, and whenever it becomes equal to the OCR0, then it will stop the counters in a CTC mode. So load first TCNT 0 with 0. Okay, load TCNT 0 with 0. So in a TCNT 0 there is a 0. Okay, in a TCNT 0 there is a 0. Now load this 199 in a OC0 register. So use LDI R20 199, OCR0 is equals to 199. So TCNT 0 is equals to 0, OCR0 is equals to 199, LDI R20 0D. Now 0D is used as here we want CTC mode plus prescaler. So in a TCCR0, according to that there is a change of bit. Okay, so LDI R20 0D. So TCCR0 is equals to 0D. So timer 0 CTC mode and prescaler is equals to 1024. Now continuously read TIFR register. In TIFR register, whenever this OCF is equals to, OCF0 is equals to 1, then we have to jump to the next instructions when counter stops. But if there is a OCF0 is equals to 0, then it jump over the again. Okay, at again loop. So it will continue up to when OCF0 is equals to 1. Now when OCF0 becomes 1, so when in a TCNT 0 it counts all the values. Then first TCNT 0 is equals to 0, then 1, then 2, 3, 4, and it count up to 199. So from 0 to 199 it counts total 200 clocks, right? So whenever this TCNT 0 is become equal to the OCR0, then this OCF0 equal to 1. So it will stop the counter by making TCCR0 is equals to 0, 0 and clear TIFR. So this is how this CTC mode works. In a CTC mode we have to load 0 in a TCNT 0 and load values in a OCR0. Okay, so this is timer 0 in a CTC mode in a assembly. Now let's discuss timer 0 CTC mode using C. Okay, so timer 0 in CTC mode in C, write a program to generate a delay of 25.6 millisecond. Use timer 0 CTC mode with prescaler 1024 XTAL 8 megahertz. Okay, so here TCNT 0 is equals to 0, 0, then OCR F0 is equals to 199, TCCR 0 is equals to 0x0D, while TIFR and 1 less than OCF0 is equals to 0, then TCCR is equals to 0 and TIFR is equals to 0, 0 or 0, 1 depending on our conditions. Okay, so this is how this timer 0 can be programmed in a CTC mode using C. So these all are the timer 0 programming. Thank you.